Be right back. We have a little issue. I think now it's reconnected. Let me check
Okay.
on the restream. Yeah, it's reconnected. So I let me fix this stuff here. Be right back. So the Zoom scene. Let me fix that. It's Zoom meeting. Zoom meeting. Okay. Now should be good. Sorry about this little issue, technical issue we have. Now it should everything should be fine. We have some issue on the OBS side that we are using for streaming. And Roberto, yeah, I think we just lost the one step,
Yeah, okay.
the image scan, but for the
Yeah,
rest
the
we
image
should be okay.
scan. This is the interesting one because we are using this OpenShift pipeline and using the RockCTL. RockCTL is a command line tool for integrating in every CI/CD tool and going also, for example, in this case, we are scanning the application that the image that we built, and also we after that application build, we can see directly a very nice report of our own image that uh, we already checked. So we have in here a lot of information and a lot of things of the different information that we have of our application. So you can check in here that it's Spring Pet Clinic with the SHA, and we have the different CVEs that we can get more information. For example, we have these CVEs and so on. This is good stuff, but also we can check different things among the image that we already built. For example, we don't want to anyone have the package manager in the image. And for this reason, this system policy failed because detect that in one layer of the image that we already built have npm or yum. Or on the other hand, for example, have vulnerabilities that could be fixable with modern scoring of 7. So these vulnerabilities are defined in ACS and are fully managed. And on the other hand, we can check this. This is from build, and we can stop our build. Imagine that you don't want to, in any way, to build your image. So you can enforce this guy in order to, if there is any CVE detected in your image build, stop and fail the build. So you can prevent your developers to bring applications or bring or build different images containing CVEs or containing different things that you don't want to. Imagine that you are detecting a shell shock or a heart bleed in your image. You need to prevent to deploy this image. And also, in the deployment check, you can check not only in build, also you can check the deployment of your own application. In this case, we are checking the different deployment of Kubernetes. In this case, we are checking amongst the different system policies, the different Kubernetes checks. In this case, for example, we can check what are the system policies. The system policies of ACS divided in three layers: in build, in deploy, or in runtime. For example, the thing that we noticed before, I, as a security team, don't want that my developers build any image that have CVEs with scoring more than 7. So we can check and we can enforce that, and we can just, for example, give them a heads up in order to, guys, you are building images that have this type of CVEs. Please solve them, because if not, could be introducing some risks. But on the other way, you can also have the possibility to enforce. Why is it enforced? So you can have the possibility to kill the pipeline itself. So when you are building the pipeline, if you are not complying with my policy, this checks and fails the build and prevents that anyone builds the image or just deploys the image. So in this case, StackRox ACS will fail when the image matches the condition. And if we rerun this, we will see, meanwhile, I will rerun this, start a run. You can see that effectively will fail the pipeline. But if we go to the pipeline, the last pipeline, also, we can check other things because the magic of GitOps happened. And why the magic GitOps happened? Because we have in here one step that it's update deployment. We automatically in this pipeline and in the GOX server, we pushed and we changed the image one specific shard. So now the image is pointing with DDD4. This is the image built in our process, the image that went through the different stages of security as well. So it's good stuff because automatically you are pushing and you are changing the code without manual intervention. And this will notice and will spins up the different Argo CD application. And if you go to Argo, now we have in here a very nice deployment that it's already live. And in this deployment, if you check the pod itself, the pod have the DDD4, the DDD5, that it's the exact same application that we already built. But everything that it's okay. So if we go, for example, in to our application and to our namespace, we will see, let me handle this in the DevSecOps. Yeah. And we have in here our Sprint pet cleaning application that we built in a very secure way. And also in the topology and also in the pipeline, we introduce 2 steps more. That is the performance test. And this performance test, we are using Gatling. This Gatling, it's using and it's trying to load a lot of requests to our application. It's like a loading test. And it's producing in a very nice way that we can check in the reports. So we have these reports in here. And if we pick the reports, we can check our application here. And if we check this, we can check, first of all, the different dependencies, and we can check the dependencies that we built already in the first place. But also, we can check the Gatling, that is different requests that we try to reproduce in order to know if our application is okay or not. And afterwards, finally, pen testing. Pen testing for what? Because when we have already built our application, we need to check from outside, simulating different attacks and trying to pen test our application in order to know, for example, if the Hellblade vulnerability is okay or not, or if we are using any weak authentication method or anything else, retrieving more information. Returning to the pipeline itself, we can see, let me rerun that because sometimes fail. We can see the different system policies and the different topology. I will shut down this. the good thing is that in the system policies, also the system policies, we can integrate information with different notifiers. In this case, I used Slack. So I used and I integrated ACS with Slack in a very easy way. And now that we have in here, we can check, for example, if anything happens during the build. For example, I can check if one application or if one build is against the different system policies. For example, in this case, I'm checking that this specific build of this container have not the specified request or limits. So the good thing is every system policy, every policy that we already deploy, we can integrate into our systems. In this case, for example, it's very easy because we can integrate this policy automatically, enabling notification with Slack. But they are already different. Like, for example, you can, if the build fails, open a Jira ticket, or just integrating with Splunk for seeing the different violations, or just integrated with Microsoft Teams as well, generating a channel. So this is a very nice way to try to get the information that for your team and for you matters, in order to not receive 1,000 notifications at a second. Only the notifications, only the things that for you already matters, in a very nice way. For example, you have in here, and they are already detected that in the deployment, your application have, for example, the different things that includes and could include the NFN, the DNF or RPM or YAM. And also give you the remediation. And this is very nice because you can give the developer the different tools and the different information in order to, hey, Mr. Developer, you are building something that are not okay, that are not complying with my different policies that we already defined.
That is super cool. It's a compliancy system where you can keep everything in pace with your definition, system policies, integration. Right. I imagine one cool integration is going to be the ticketing system, no?
Yeah.
For enabling your process. What very cool.
Yes, yeah. And to be honest, I think when it comes to like educating the developers to think more in a security point of view, they're going to start thinking about like the base image, right? So they need to be aware. They need to start asking questions like, is my base image updated? So what type of tools are existing in that image? So do I have core? Do I have wget? So you don't need wget on those images, right? So how many vulnerabilities exist within that image? So the ACS allows the developers to be aware exactly what type of like problems they can have in production, because you don't want to basically ship you don't want to introduce new problems in your production environment, right? So ACS allows you to educate your developers like even before having problems during the build phase.
Yeah. And also preventing, for example, and enforcing. Imagine that you in production don't want anything that can be built with this EVE or with the RPM, or just not using requests or limits. You can prevent that. You can check that your own deployment, your own name of DevSecOps can have also the information about you don't have this request or limits. And also the rationale for what, and the remediation as well. Giving this information directly to the developer and shifting left and adding more security layers and more information and more power to developers to solve the problems, not only for the security teams to be sticking around and giving the heads up every time to the different development teams. This is very, very good. And also you can enforce. So you can prevent that if these checks into the development team, if this fails, you can prevent to deploy the different application or to fail the CI itself. So if we see that it's building the image, so in a couple of minutes, we can see that effectively this, when reach the image check, fails one specific system policy that we defined specific with CVSS, because we define it in here and we enforced. So in this enforcement, if this policy don't fail this policy against our image, because our image checked and we noticed that we have any CVE that goes more than 7 in the scope, will fail automatically the CI and will prevent anybody to.
This is during the build phase, right? So if you want to protect like production, you should set on the deploy as well. So that's gonna basically block any creation of the deployment with that problematic image.
Mm-hmm.
We have a question from the chat. There's Mvatsje asking, can you create the custom violations? Is there any integration with Open Policy Agent?
This is a very good question. You can define it wherever you want, and it's very, very, very easy to define new policies, to define the severity, and also the life cycle stage. For example, you don't want to prevent, you want to prevent to specific CVE to pops up. So you can prevent in the deployment, goes to the description, and after that, for example, you can restrict and also enable the notification. With that, you can define whatever you want. In this case, for example, with a lot of things that affects in build, in deploy, and in a runtime. Imagine that you want to, you don't want to have the possibility to the developers to deploy one image that have a CVE. So you can define the specific CVE. In this case, for example, whatever you want. In this case, we can use the example CVE that it's called 28.
Well, the nice thing, as you can see here, so it's very user friendly. So it's basically drag and drop. Yeah, basically you can build your policy criteria based on drag and drop. So
yeah, and you can, for example, prevent that anyone deploys a privileged container, adding certain capabilities. For example, I can define it that no one can deploy one pod or one deployment with a certain capabilities, and I don't want to allow that, or at least just inform it. And when we have it here, we can define it, the enforcement. So if anyone tries to, in production, in whatever you want, to deploy in specific deployment with a pod with a certain capability or with a certain CVE, we can prevent and automatically ACS through an admission controller, the policy admission controller, will fail. That it's more or less the same thing that it's having with OPA, but in a very, very nice way. Because with here, you can drag and drop, as perfectly said, Rodrigo. And we can, for example, define a lot of situations like SEPCOM, privileged containers, and so on. It's a very nice way to define it and to control your different policies. So you can define your own policies.
And at this stage, I don't think there's any integration with OPA and ACS.
Mm-hmm.
I think it's going to be something similar to ACM, right?
Mm-hmm. This checking with the PMs, and in the future we'll have different things. So, okay. Oh, cool. And finally, we have in here that effectively we defined the image check. So the image check we have a violated policy because these have an enforcement. So if we have it, and if we check the fixable CVSS, we see that we have this policy enforcement that caused the failure of the whole CI/CD pipeline automatically, because doesn't fill and doesn't pass our compliance, because I don't want to anyone put any CVE building my image. And also you have more information, because in the image check, the developer can have the possibility to check, okay, this image fails, but for what reason? I need to have more information. I need to check. So we can bring this, this CVE and automatically know to which components are affecting, to which deployments are affecting as well, and also having more information, going directly to the information source. And this is a very nice way to do it. So you can control in a very nice way the different things that you have, giving the possibility and giving to the developers more tools in order to control in the full pipeline, even having the possibility to full control the pipelines of your developers and enforce your compliance security policies. And that's all for our side.
Wow, I mean, it was super, lots of stuff. I think, you know what, I think this reserves also a second session where we go into more details. We had some, I'm sorry for our attendees, we had a little issue on the streaming, so the stream gets splitted in two, but we will make sure to join the two recording. So sorry about that, but we were able today to see a complete DevSecOps demo. Really, congratulations, Roberto and Rodrigo. That is awesome. And actually, I know there's a repository if people want to.
Yeah, sure. I can show the repository as well.
I think if it's the one, the DevSecOps demo one, the one you shared with me.
Yeah, that's the same. Yeah, you have more
information.
And
time flies. So I was expecting to have time to show how to deploy ACS on CRC, for example. There are some tweaks that you can do with a resource that basically you can have ACS running on your laptop using CRC. But
that's
maybe next time.
Interesting. Let's do this, folks. It was so interesting that I think it deserves a series, a DevSecOps series. We can have some kind of, we did this introduction. For the next time, we're going to do a series where we go into CRC or local development with ACS. And I would like to see also the penetration testing, the vulnerability assessment. We have seen the whole pipeline today. Maybe we can focus more on the vulnerability assessment of live violation. Like I have my application running. This application is doing a live violation. So we have seen the CI part. What is, and we talked about the CD part with the Argo. I was wondering if we have something to say also on, running processes.
Yeah, we can.
Yes, of course.
A lot of things with the running and detecting also the violations, for example, preventing if anything goes or if anybody do a netcard or an nmap inside of our container, prevent to do that and itself also kill the pod if this will enforce it or not. So we can have this series for sure.
Yeah,
fantastic. Of course. I'm looking forward to it because it's so interesting. I think people really enjoyed also in the chat. There was lots of interaction. I just shared the demo. So the demo was made by Roberto and Rodrigo that worked in this fantastic demo. I really recommend to try it out. You know what? You can try on CRC, for instance, which is a local development for OpenShift. And you can try on any of all your OpenShift cluster available that I'm putting in the chat, the link to, start trying OpenShift, start trying ACS. which is now GA. And you can deploy the demo that Roberto and Rodrigo today made for us. So, you know, I would like to really thank you for this awesome demo. Recording will be available on the OpenShift YouTube channel. And you know what? We will see again here at OpenShift Coffee Break with a new DevSecOps series, because it's so cool, so interesting. I really enjoyed. So thanks, Roberto and Rodrigo, for joining us
welcome.
today.
My pleasure.
And, see you next time.
See you next time. And for us, folks, you can stay today on OpenShift TV. We have our regular schedule. If you would like to stay, that goes into from you know, EMEA afternoon time, and then it goes into the normal schedule. If you go to OpenShift TV, you see all the schedule that we have. Let me put the link so you can follow with next things. Today we have lots of also episode our recurring series, and we see each other for our next appointment. That will be July the 28th. We will come back with a pipeline as a code topic together with Jafar and some people from the engineering talking about Tecton pipelines as a code. So thank you very much for joining today. Thank you for attending. Look forward to see you on the next OpenShift Coffee Break episode. Ciao.
Thank you. Ciao. Bye-bye.